In this video, you're going to learn what a polyatomic ion is and which ones you may need to memorize. So let's go ahead first and take a look at this word polyatomic ion. Okay, we know poly means many. Atomic refers to the number of atoms. So many atoms, and it's going to be many atoms together to make an ion. So that's what a polyatomic ion technically is. It's just an ion that's made up of a bunch of atoms. Up to this point, the ions that we've seen are known as monoatomic ions, meaning they're only one atom. For example, the chloride ion looks like this. It's made up of only one atom, and it has a charge, which is making it an ion, or something like this. Again, just one atom with a charge. A few examples of polyatomic ions are like nitrate, for example. Nitrate is NO3 negative. So there's a total of 4 atoms there. There are 3 oxygen atoms and 1 nitrogen atom. So when 1 nitrogen atom and 3 oxygen atoms chemically combine, they form a polyatomic ion that has an overall -1 charge. Depending on the polyatomic ion that you have, you may have different number of atoms. For nitrate, like I said, there are 4 atoms. However, something like hydroxide looks like this, and there are only 2 atoms there. There's 1 hydrogen atom in hydroxide and 1 oxygen atom in hydroxide. So when one O comes together with one H to form an ion, it makes an overall -1 charge. And because there isn't a way to predict out the charge, many times teachers will ask their students to just memorize all of the polyatomics that are going to be used in the class. Typically at the high school level, they'll be given to you by the teacher, but at the college level, you'll need to memorize all of the polyatomic ions. And while there are a lot of them, typically if you need to memorize them, your teacher will have you memorize 20 to 25 polyatomic ions. But it's always best to ask your instructor if they want you to memorize them or not. And if they do want you to memorize them, you obviously need to find the chart that they want you to memorize with all of the polyatomic ions that they want you to memorize. Because there are actually over 50 polyatomic ions, but they're not going to have you memorize all 50 probably. They'll probably only want you to memorize the ones that you're going to see most often in the class. When you're actually writing the formulas for polyatomic ions, one thing that you need to be really careful of is the placement of the subscript and the charge. For example, phosphate is PO4 -3. The thing I want you to notice here is I've put this 4 way down below and close to the oxygen because that's 4 oxygens, and the -3 I've put way up high and to the right of the whole thing. So we need to make sure that there's plenty of distance between these two numbers, and that this one is way down at the bottom as a subscript, and the charge here we need always as a superscript. So make sure there's lots of distance between those. When you don't, and you get sloppy, you get things that look like this, which will always be counted wrong or counted off by whoever or whatever you're using them for. Also, like any other ions, you need to always include the negative sign or plus sign unless it's just a 1. For example, one polyatomic ion is ammonium, and ammonium has a +1 charge. So you want to write it like that versus writing it like this. Here, this is confusing, the second way I've written it, because it almost looks like it's a 4 plus something, but it's not. It's really 4 hydrogens with a +1 charge. So make sure that you're writing it properly again and including the plus or minus in your charge. And again, that's the way we don't want to write it. The last thing that I really want to mention is that some polyatomic ions might have multiple names, and you might be required to know both names for the polyatomic ion. For example, HCO3 negative is a polyatomic ion. It can be called hydrogen carbonate, or more commonly it's known as bicarbonate. And so out in the real world, when you're looking at ingredients on boxes and things like that, typically you'll see it written as bicarbonate over hydrogen carbonate. Almost all of the polyatomic ions are negatively charged. There's one cation that's a polyatomic ion, and only one. It's ammonium. And the IUM should be the clue that it should be the clue that it's going to be a positively charged ion. Ammonium looks like this. The other thing that you might want to be aware of is that some ions, or polyatomic ions, you can write the formula several different ways. An example is not acetic acid, but acetate. Okay, so acetate, depending on what textbook you're using or what teacher you have, you may see it as CH3COO negative. You may see it as CH3CO2 negative. Or you may even see it as C2H3O2 negative. In all cases, you'll notice that it still has a negative charge, but the way it's written is dependent on what kind of class you're in and what the use of it is. But you can see in this way there are 2 O's there are the 2 carbons and the 3 hydrogens. And in this way there are our 2 carbons. We've put the O's together to write O2. There are still the 3 hydrogens. Or in this way, both carbons are put together, all 3 hydrogens are put together, and both oxygens are put together. So just be aware of a few of these things like this. One other real quick thing that I thought about I wanted to add into this video here is understanding that when you're adding hydrogens to polyatomic ions, you're reducing the charge. And the reason is that hydrogen, when added to a polyatomic ion, usually has a +1 charge. So for example, carbonate is a polyatomic ion that's CO3 negative 2, but hydrogen carbonate, or remember it's also called, and more commonly called, bicarbonate, where bi does not refer to 2 but actually refers to the addition of hydrogen, is HCO3. And because we added the H, we're adding a +1 charge to this, which is going to make it -1, or just negative. And just like monatomic ions, it's okay to not include the number and just the negative sign. That's totally fine.